All right, so this is going to be our walkthrough for the homework assignment titled Basic Rectangular Approximations. So what we're going to be asked to do for each of these is just to do a left, a right, and a midpoint rectangular approximation to find the area under the curve on the interval given, and we'll be given a number of subintervals. So remember, these are just approximations for what this area underneath the curve is. So we'll start with the left rectangular approximation for this one. But really, before we do that, let's think about what's going on here in the question. We've got the function y equals x cubed, and we're talking about the interval from 1 to 5, and we're talking about 4 subintervals. So those subintervals should be from 1 to 2, from 2 to 3, from 3 to 4, and from 4 to 5. Right? That we can always find that by doing the length of each of the subintervals by doing b, the 5, minus a at the beginning of the interval, 1, and dividing it by n, the number of subintervals, which tells us that the length of each of our subintervals is just going to be 1, right? Which means we're going to go from 1 to 2, 2 to 3, 3 to 4, and 4 to 5. So to do a left approximation, then all we need to do here is take the length of each subinterval, 1, and then multiply it by the left endpoints of each of those subintervals, and those values plugged into our function, right? So it's 1 times f of 1 plus 1 times f of 2 plus 1 times f of 3 plus 1 times f of 4, right? And we don't have to do anything else with the 5 at the end because we're only doing the left endpoints, right? And f of 1, f of 2, f of 3, and f of 4 are just 1 cubed, 2 cubed, 3 cubed, and 4 cubed. So and if I'm just multiplying those all by 1, I don't really need to write that. We have 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed. Well, that'd be 64 plus 27 plus 8 plus 1, which comes out to be 100. So the left approximation there is going to be equal to 100. And then we'll do the right approximation. Right? And for our right approximation, we're just going to do the right-hand endpoints there. So we're looking at 1 times the right endpoint of 2 cubed plus 1 times the right endpoint of 3 cubed plus 1 times the right endpoint of 4 cubed plus 1 times the right endpoint of 5 cubed. And so if I just add all of those together, that's going to be 125 for the 5 cubed plus 64 plus 27 plus 8, which comes out to be 224. And if we were going to do the midpoint approximation here, and our midpoint approximation, we're going to take the midpoints of each of those intervals and evaluate our function at them. So the midpoint of 1 and 2 is 1.5, or 3 halves. So we have 1, the length of the subinterval, times 3 halves cubed. And we'll add to that 1, the length of the next interval, times 5 halves cubed. And then we'll add to that, again, 1 times the midpoint of the next one, 7 halves cubed, and 1 times the midpoint of the next one, which is 9 halves cubed. And so then we'll just, do all of that arithmetic there, and we're going to end up with 8s in the denominator there. Let's see, we've got 27 plus 125. 7 cubed is 343, and 9 cubed is 729. And so all of that divided by 8. And if we add those together and divide by 8, 729 plus 343 plus 125 plus 27 is 1224. 1224 divided by 8 just gives you 153. So for our next one here, we're just looking at a new function, negative x squared plus 8x minus 12 on the interval from 2 to 6 this time. And so we've got 4 subintervals. So again, if we take b minus a and divide it by n, our number of subintervals, we just get 1. So the length of each subinterval is 1. So we're looking at 2 to 3, 3 to 4, 4 to 5, and 5 to 6. And so if we're going to do the left approximation, each of them have a length of 1. So in fact, this time I'm just going to write the 1 out in front. And then I'll do f of 2 plus f of 3 plus f of 4 plus f of 5. Right? And so that's going to end up giving us here, let's see here. So the 1, of course, is insignificant. F of 2 is going to be negative, the negative of 2 squared, so that's negative 4. And then negative 4 plus 16 minus 12 is 0, so f of 2 is actually 0. And then f of 3 is negative 9 plus 24 minus 12, which is just 3. And then f of 4 is negative 16 plus 32 minus 12, which is just 4. And then f of 5 should be negative 25 plus 40 minus 12, which is just 3. Add those together and you get 10. For our right approximation here, we're just looking at, again, 1 times our right endpoints, which will be f of 3 plus f of 4 plus f of 5 plus f of 6. And when we do that, f of 3, we actually just found f of 3 a little bit ago. And f of 3 was 3, and f of 4 was 4, and f of 5 was 3, and then f of 6 should be negative 36 plus 48, which is 12, and then minus 12, which is 0. So it actually ends up being exactly the same thing there. And then for our midpoint approximation, we're just going to do, again, 1 times f of, and this time it's going to be f of, our midpoints there are going to be, let's see here, 2 to 3 should be 5 halves, so f of 5 halves, and then plus f of 7 halves, plus f of 9 halves, plus f of 11 halves, right? And so we'll just plug each of those in into our function there. And so let's see here. If we do negative of 5 halves squared, that's 25 fourths. And then plus 8 times 5 halves would be plus 20 minus 12. That comes out to be 7 fourths. And if we plug in 7 halves, that's going to be negative 49 fourths plus 28 minus 12, which should be 15 fourths. If we plug in 9 halves, that's going to be negative 81 fourths plus 36 minus 12, which is also 15 fourths. And then when we plug in 11 halves, we're going to get negative 121 fourths plus 44 minus 12, which comes out to be just 7 fourths. And if we add those all together, we get 15 and 15 is 30, plus 14 more is 44. 44 fourths ought to be 11. And we should be able to see that the vertex of this parabola is at 4, which was making it really nice and easy to evaluate some of these, right? Because on, if we're at 7 halves and 9 halves, those are, 7 halves and 9 halves are equal parts away from 4 on the other side of it, so the value should be exactly the same. Same with 5 halves and 11 halves. So, yeah. So for our next one here, we just got a new function, negative 1/4 x squared plus 10. This time we're going from negative 6 to 6, and we're doing 6 subintervals. So in order to figure out the length of the subintervals, we should do b minus a and divide it by n, the number of subintervals, right? And this is always the interval from a to b here. And so that ends up being 2, right? We get 12 over 6, which is 2, which means the length of each of these subintervals is 2 units. So we're looking at from -6 to -4, and then -4 to -2, and then from -2 to 0, 0 to 2, 2 to 4, and 4 to 6 as our 6 different subintervals here. And so when we do our left approximation, we're going to do, this time it's going to be 2 times all of them because the length of the subintervals are each 2. So it's 2 times f of -6 plus f of -4 plus f of -2 plus f of 0 plus f of 2 plus f of 4. And so that will, let's see what that comes out to be. That'll be 2 times, so f of -6 should be -6 squared. That's 36, and then times -1/4 is -9. Plus 10 should be 1. And if we plug in -4, that looks like that should come out to be 6 if we plug -4 into our original function there. And if we plug in -2 into that original function, we get 9. And if we plug in 0 to that function, we should just get 10. And then plugging in 2, we're going to get 9 again. And then plugging in 4, we're just going to get 6 again. And so if we multiply each of those by 2 and add that all together, we end up with 82. And for our right, we're still going to have 2, and now it's going to be times the right endpoints of all of these. So that'll be f of -4 plus f of -2 plus f of 0, f of 2, f of 4, and f of 6, which is going to be 2 times, well, we already found f of -4, -2, 0, 2, and 4. Those were just 6, 9, 10, 9, and 6. And then we would need to figure out what f of 6 was. Well, f of 6 is just, it ends up being the same thing as f of -6. Right? It's 6 squared is 36 times -1/4 is -9 plus 10 is just 1. And it looks like we end up actually getting the exact same thing again here. And for our midpoint approximation, we'll still do 2, but now we're going to take the midpoints of each of these. So that's going to be f of -5 and f of -3, right? F of -1, f of 1, f of 3, and f of 5. So if we evaluate each of those, f of -5, we'll put our 2 out here. F of -5 should be -5 squared, which is 25. So -25 fourths plus 10 ought to be 15 fourths. And f of -3, well, that's going to be -9 fourths plus 44, so that'll be 31 fourths. And then the next one, at f of -1, we should end up with -1/4 plus 40 fourths, so 39 fourths. And then we'll get that again, right, as we do our next one there at +1, right? We should get 39 fourths again, and the same with 3. For each of these, we're going to get the exact same thing as we got with the negative version of it. And multiplying all that by 2 just turns those all into halves. So if I add all the numerators together, well, 31 and 39 is 70. And I have 2 of those, which makes 140. And then 2 15s will make 170. So I have 170 over 2, which is 85. All right, and for our last one here, we're looking at 2 subintervals from 1 to 5 for the natural log of e times x. So we've got two subintervals. We're going to do b minus a over n, which means that each subinterval should be a length of 2, right? Which means that we're going to go from 1 to 3 and from 3 to 5. And so as we do this, we have for the left 2 times f of 1 plus f of 3. Well, f of 1 is just the natural log of e times 1. Natural log of e is just 1. So we've got 2 times 1 inside of there now. Plus, if we plug in 3 to that, we've got the natural log of 3e. And then we could simplify this down a little bit, right? If we rewrite this, is 2 times 1 plus the natural log of 3e. That's two things being multiplied together inside the logarithm. So that could be turned into the two of those things in separate logarithms being added. And we know the natural log of e is just 1. So now we have 2 times 2 plus the natural log of 3, or we end up with 4 plus 2 ln 3 with our left approximation. And for our right approximation, and the arithmetic here now should get, now that we kind of have an idea of how to do it, it should be pretty easy here. It's 2 times f of 3 plus f of 5. Well, we already knew that f of 3 was the natural log of 3e, and f of 5 was the natural log of 5e. And so we should just be able to rewrite each of those. Right? The natural log of 3e is just, like we said before, 2 plus the natural log of 3. So we have 2, and then we have 2 plus the natural log of 3, and then this one should be the natural log of 5 plus the natural log of e. So that's going to be plus another natural log of 5. All right, so we got the natural log of e from the natural log of 3e and the natural log of e from the natural log of 5e. Those are both 1, so added together that makes 2. And then we're adding together natural log of 3 and natural log of 5. And of course, natural log of 3 plus the natural log of 5 can just be the natural log of 15. Okay. So this is equal to 2 times 2 plus the natural log of 15. And so we can rewrite this as 4 plus 2 ln 15. And of course, just to note, like if these were multiple choice answers, you might see something like 4 plus the natural log of 225. Or even for this one, you might see 4 plus the natural log of 9, right? Pulling that 2 inside as an exponent. So either way you choose to write those is just fine on a free response. But if it was a multiple choice, just make sure that you're able to do either one. And for our midpoint, we're going to have 2. And then the midpoints of 1 and 3 is 2. So it's natural log of 2e. And then natural log of the midpoint of 3 and 5 is 4. So the natural log of 4e. And, well, we'll do a different simplification here for this. This time it's 2 times the natural log of, I can just put those together as 8e squared, right? Well, that's the same as 2 times the natural log of 8 plus the natural log of e squared. Well, the natural log of e squared is the same as 2 natural log of e, which is just 2. So this is 2 times 2 plus the natural log of 8, which of course is 4 plus 2 ln 8, which is perfectly acceptable. Or you could write it as 4 plus the natural log of 64. Either one would be good. And that's the end of our walkthrough for this homework assignment.